So this is the integration by parts formula, and I'm gonna just use it and see if I can do the problem that you had. So let's see. So here's what you have. Here's the integration by parts formula, and I think I'm gonna do it a little bit differently than what Khan Academy does. But if we just start going, we're gonna choose a u value. We're gonna choose a u. You can't see that. Choose a u. We're also gonna choose a dv, and we're gonna go. So this is how you do it. So here in this particular problem, I'm gonna choose u to be 2x, and then du, that's just the derivative of that, and that would be just 2. So I choose a u and I get the derivative. And then I also choose a dv, right, because my integration by parts formula has a u and a dv to begin with. Those are our two parts. So my dv is going to be sine x dx. So my dv is going to be sine x dx. Sine x dx. I don't know if I want to say it this way, but here, to get a regular v, I'm going to integrate. Well, the integral of sine x dx is, what, negative cosine, I think? Right, because the derivative of cosine would be negative sine. So the antiderivative of sine would be negative cosine. So there we go. And now I can use my integration by parts formula. So this integral, which is u dv, that's going to be equal to, and we're going to do it, I guess, without limits of integration, I guess, I don't know. We're going to have u times v, well, that would be u, 2x, times v, so negative cosine of x, and I'm just following the formula, that's u times v, minus the integral of v du. V, which is negative cosine, so I'll change that to plus cosine x, and then du. Well, that's nice because du is just 2. So I'm going to just move that out in front and tack on a dx, I guess. I don't know. So we'll see. Just see if this works. Hopefully it does. I don't know if it will. I haven't done this in a while. Sorry. The whole point of this is to, we have this part, which we don't need to do anything to now, and then we have this part, which we can take the integral of easily, because the antiderivative of cosine would just be sine. So we have 2 sine x, and then plus c. We don't really have a c value, because we're going to evaluate all of this from 0 to pi. So let's rewrite this a little bit more neatly. I'll have negative 2x cosine x plus 2 sine x, all of that evaluated from 0 to pi, so you plug in the pi first, so that'll be negative 2 pi cosine of pi plus 2 sine of pi minus 2 times 0 cosine of 0, those will go away, plus 2 sine of 0. Okay, well, what do we have? Cosine of pi, that's negative 1, so I have negative 2 pi times negative 1 plus sine of pi is 0, right? Yes. And then that goes away to 0. And then sine of 0 is, well, also 0. So is this really just 2 pi? Oh no, I'm going to look it up. Yep, that's it. Integration by parts. That's the right answer. So, what the heck did we just do? Well, if you have, integration by parts is kind of like the reverse product rule. That's how I think of it, at least. Here, I have a product, and I want to integrate them. I want to go backwards. Normally we do a product rule if we take the derivative, but we don't have that. We have integration by parts. So if you have two functions, the 2x and the sine x, if you have two functions multiplied together, one of those functions is going to be your u, and one of them is going to be your dv. So you got to choose them. And I could have chosen it. I could have chosen it to be the other way around. I could have chosen sine x and then 2, like sine x. This could be u, and this could be dv. If you play around with it a little bit, you'll be able to see like which one should be which. Usually, you want your u's to get simpler. So anything that gets more and more simple as you take the derivative, that'd be great. Anything that's kind of like complex or like doesn't really go away, that'd be the integral. But sometimes, if you have, I don't know, some functions, they like kind of get more simple as you integrate them. So you'll just have to choose based on just trying. Choose a u, choose a dv. You get a du by taking the derivative. You get the regular v by integrating. And then you just plug it into the formula. There you go. I don't know if that made sense, but I'm going to be done with this video. I hope it did. Choose a u, choose a v, anytime you have an integral with a product of two functions. And then use the integration by parts formula. Alright, I'm done.